In this section of the course, we're going to be taking a look at the range object, which is the most popular object in the Excel object model. A range object is a grouping of one or more cells in a single worksheet. So to clarify, Excel does not have the concept of a cell object. Rather, a cell is just a range that targets only one cell. The range object is kind of the catch-all tool that we use to target anything from one cell to a clump of cells to all the cells on a single spreadsheet. A range is built around A1 notation, which is a technical term for a concept that we're actually pretty familiar with. A1 notation simply means that we refer to a column with a letter and we refer to a row by a number. So A1 comes from the top left cell in a worksheet, which is right here, cell A1. We use the letter from the column and we use the number for the row, and that represents how we're targeting the address of a cell. As we know, the range object is a property of the worksheet object. The worksheet object is nested under the worksheets collection. The worksheets collection is found within the workbook object. The workbook object is nested within the workbooks collection, and that collection of workbooks is nested under the application object, which sits at the very top of the Excel hierarchy. A range can provide a qualified reference, which means we can tell it specifically what workbook to use and what worksheet to target in that workbook, but we can also target a range without mentioning any of those characteristics. A range without a qualifier will assume the active workbook and the active sheet. The active workbook, of course, is the workbook that is currently active. It's the one that we're clicked into, that's selected within our Excel application. The active sheet is whatever sheet we currently have selected within that workbook. So for example, in this Excel workbook, I have two sheets, sheet 1 and sheet 2. The one that is highlighted, the one that is activated, is called the active sheet. So sheet 1 is the active sheet. Now we have to be careful here because there's actually two types of sheets available in Excel. A regular spreadsheet, which is the one we see right here, or a data sheet. And the second one is called a chart sheet, which is used to render a chart, like a pie chart or a bar graph. In that case, those chart sheets don't actually have a range property on them. So if the active sheet is a chart sheet, then the range property will not exist and we're going to run into an error. So whenever we have the potential to run into that error by having chart sheets, it's a better idea to include explicit references to the actual sheet that we want to target. In this course, we're not going to be diving into charts until much later, so we don't have to worry about that right now. All of our sheets are going to be data sheets, spreadsheets, so whenever we use range, we can be certain that we're not going to run into that bug. In this lesson, I want to dive into the select method, which simply selects or highlights a range on the worksheet. This can be a particularly useful tool when you want to double check that the reference that you're providing to a range is proper and that you're targeting the right thing. So let's take a look. I'm going to define a procedure here called highlight range. And we're going to do some pretty simple statements right here. But again, this is just to get us thinking about what a range can hold. So of course, a range can select a single cell. So for example, I can do range right here, target a cell like B5, and let's execute the select method on the range. All that's going to do is highlight the cell. So when I execute this, we can see the little green box has moved to cell B5. Whenever we select a range in Excel, we actually get access to that very same range with a property called selection. So right below here, what I can do is target selection, which right now is cell B5, and let's say write a value into there like hooray. So I'm just going to execute this, and we're going to see that that value is going to be populated in cell B5. Now right now you may be looking at this and saying, what's the point of this? Can't I just do range B5 dot value equals hooray? And the answer is you absolutely can. But imagine a macro that you'd be running where you want to ask the user to actually select some cells. So you want the user to actually do the highlighting. What you can do is target that highlighted collection of cells with something like selection. And that allows us to be very dynamic. Our macros no longer even have to reference any specific range because we're going to dynamically be able to figure it out by what the user has selected. So whatever is currently selected, for example, this selection or this selection, this is going to be represented by the selection keyword or property within VBA. So range actually offers us a wide variety of syntactical options to refer to a cell or collection of cells. So we know here that we can select a single cell by just writing it in as the A1 cell reference. What we can also do here is actually specify a range or a collection of cells with a colon. So if I want to target, for example, cells B3 through E9, I can write it like that. That's going to select that entire range of cells. We can also separate these arguments and put them in as two different arguments to that range. So what we can do here is write our first argument, which is going to represent the top left corner of the range that we want to target. And the second argument is going to represent the bottom right corner of the range that we want to target. So we're basically creating almost like a square where we're specifying the top left and the top right. It is going to result in the exact same thing. So we can see here we're selecting the exact same box. Two different ways to accomplish the exact same task. We can also use the range syntax to reference a whole column or a whole row. So for example, if I want to target all of column E, what I can do is just write E through E. Then when I execute this, I'm going to select just that column. If I want to target more than one column at a time, for example, let's say I want to target B through F, I just begin with my first column, colon, my ending column. That's going to select all of the columns there. I can do the exact same syntax for rows, but instead of providing letters, of course, I provide numbers to represent rows. So if I want to target, let's say, row 3, I can just do row 3 through row 3. That's going to target that. And let's say I want to target rows 7 through 12. It's just the beginning row, a colon, the ending row, and that's going to select that entire range of rows. Here's another cool feature that's available with range. We can actually make up a range of different non-contiguous cells. What that means is the cells don't have to be connected to each other. That's what non-contiguous means. So, for example, let's say I wanted to select cell A1 and then another clump of cells like B2 through, let's say, B3. What I can do is actually put a comma after my initial reference and then put the other reference that I want to target. So when I execute this with F5, you can see we're targeting both cell A1 right here as well as all of the cells in B2 to B3. Let's add another range here. Let's say I want to target something completely far away from those. Let's say cell D9 through G15. When I execute this, you can see we're going to target those 3 non-contiguous ranges, and all of the familiar syntax is going to apply. So once we have those selected, we can use the selection to write in a value to all of them. For example, let's do hooray again, hooray, execute that. So now we can see we've targeted these separated ranges and performed some kind of identical process on them. It doesn't have to be writing a value. We can, for example, perform some kind of formatting process or call some kind of method on all of these cells. The range object does not actually have to be cells that are strictly connected to each other. They can be separate like here. All you have to do is separate those range references with a comma in a single string using the familiar colon syntax, and that way we can target these non-contiguous ranges. That's all there is to cover in this lesson. We talked a little bit about the range object and the select method, which simply selects a range or highlights it so we can see it in the interface and confirm that it's the proper thing that we're referencing. Once it's selected, of course, it also becomes referenced by something called the selection property. So selection right here is the same valid range object, and then we can invoke whatever methods we want or use whatever properties we want on that range object. Again, the advantage of this is we can allow the user to select something first and then ask them to execute a macro that's going to target their selection, and that way we can target a dynamic range. We also talked about the many different arguments that we can give to the string to target a range. We can target a cell, a clump of cells, we can target a column, a row, we can even target non-contiguous ranges. So there's a lot of power in this simple range syntax. That's all there is to cover here, and throughout this section we're going to be diving into a lot of different things related to range. It is the most popular object available in the Excel object model. Most of our operations in Excel deal with data, writing it, manipulating it, etc., and that takes place in the range object, so that's to be predicted. I'll see you in the next lesson. In this lesson, I'll dive into the differences between the value property and the text property on a range object. So what I'm going to do here in column A is write a whole bunch of different values. I'll begin with just a regular string of hello. Then I'm going to do a regular number like 10. Below here, I want to do something interesting. I want to store a currency, so a amount in dollars. So what I'm going to do is just enter a number like $9.99. But once that's entered, I'm going to select from this drop down here and change the format from a regular plain number to a currency. So now we're going to see this little dollar sign appear in front of it. And finally, what I want to do here is to store a date. So I'm just going to enter my birthday, 4/12/1991. And then what I'm going to do is highlight this. It's already been recognized as a date by Excel, but I want to represent it in a different format. I want to represent it as a long date, which is going to include the day of the week as well. Now let's transition to the immediate window in our Visual Basic Editor, and we can take a look at the differences between the value property and the text property. So let's begin one cell at a time. For a plain cell that just has something like text, the value property and the text property are going to return the exact same thing. They're just going to give me the value or the text that's being stored within that cell. The same rule applies whenever we have a plain number like 10 in cell A2. So if I take a look at the value of that, we're going to get 10. If I take a look at the text of that, we're going to get 10 as well. Here's where it actually starts to get interesting, which is cell A3. Because in cell A3, we have the concept of a currency. Behind the scenes, a currency is just stored as a regular plain number, right? So if we take a look at the actual value, the value property returns the actual representation of the data. So behind the scenes, the only thing that's really being stored in the cell is $9.99. The dollar sign and the idea of currency is kind of like a visual add-on that Excel adds for the user so they have a little bit more context. But there's no difference behind the scenes as far as how Excel is storing this data behind the scenes, kind of the operations that Excel does under the hood. So when I take a look at the value you can see being stored in that cell is $9.99. That's no different than if I literally wrote $9.99 in the cell, the very first example. However, if I take a look at the exact same range, but this time I target the text property, we're going to get the literal text representation that exists in that cell. So the actual thing that the user is seeing in the Excel interface. That's the benefit of text. Because if we only use value, we're going to lose potentially some of those aesthetic details. That is how the cell appears in the actual interface. Let's take a look at another example with dates. So in cell A4, I have a date. And if I take a look at the value here, I'm actually going to get the way that VBA represents dates, which is just going to be the month, then a slash, then the day, then a slash, then the year. So notice that the representation of the day of the week, Friday, is not present, and neither are the commas. This is the way that VBA stores all of its dates internally. We took a look at that whenever we created the date data type way back when a couple sections ago. However, if we use the text property on the exact same cell, we're going to see that that's going to give us the way that it's actually represented as text in that cell, which is the Friday with the commas, etc. So as we've seen so far, sometimes the value and text properties will both return the exact same result, for example, hello and 10, but sometimes they're going to return completely different answers because how Excel stores data is not always the same as the way that it presents data in the Excel interface. That's the big difference between text and value. Value is going to give you the data as it's stored, while text is going to give you the data as it's presented in the Excel interface. Over the next two lessons, I want to introduce you to a different way of thinking about cells in a spreadsheet. So far throughout the course, we've relied on a specific notation for cells that we've called A1 notation. A1 notation simply means that we use a letter to represent the column and a number to represent the row. For example, cell C4 or cell F2. The reason it's called A1 notation is because the top leftmost cell in our spreadsheet right here is cell A1. So the top leftmost cell and the way that we reference it is also where the notation gets its name. But this isn't the only way that we can actually think about references within our spreadsheet. If you take a moment to think about it, there's a lot of logical jumps that we make in Excel. For example, if I was working with a coworker and I had a value here in column A, and I said, put a value in the column that's 2 to the right, the coworker would intuitively understand that I mean column C. But how are they doing that? Well, they're looking at it from a logical perspective. But from a computer perspective, from a programming perspective, it doesn't really make sense because our column is A, and how do you represent the idea of 2 to the right of A? Right? A is a letter. So if we were to try to express this as a mathematical operation, it would be something like A plus 2, which doesn't really make any sense. So as you might guess, behind the scenes, Excel is actually looking at column A as column 1. If we look at that column as column 1, it becomes a lot easier to perform some kind of mathematical range movement. If we want to move 2 columns to the right, it's as simple as saying, we're in column 1, let's add 2, we're going to get 3, and so our final destination is going to be column 3. Believe it or not, behind the scenes, that's how Excel actually works. So what we see up here with these letters is actually just a mask. It's a layer above Excel's actual mathematical model. This is just presented to the user to offer a little bit of simplicity. But behind the scenes, the columns are also represented as numbers, and that's exactly what R1C1 notation is. R1C1 notation is just a different way of thinking about range references. In this notation, we use a number to represent both the row and the column. The reason it's called R1C1 is because in this syntax, the top leftmost cell right here is row 1, R1, and the column is column 1 or C1. So that's where we get the name R1C1. As it turns out, we can actually enable a setting in Excel to bring us into this view of R1C1 where all of our columns will be represented as numbers. So we can see how Excel is actually working behind the scenes. It's pretty simple. All we have to do is go into File right here, then Options, and on this Excel Options box that pops up, there's going to be a Formulas tab. And under this section, Working with Formulas, we have an R1C1 reference style button. If I click that and then click OK, you'll notice that the columns are now going to be represented as numbers. Now, this doesn't just change the visual look of Excel, it also changes how we have to write formulas within our actual cells in our spreadsheet. So for example, let's say I put a value right here in row 4, column 2. Let's just say I write the value hello. Let's say I want to reference this value from another cell. Let's say any random cell like right here in row 10, column 8. Well, normally I would write something like row 4, column 2 in the actual A1 notation, which would be B4. But now we don't have the concept of B, so something like this is simply not going to work. We basically turn that option off when we enable this R1C1 setting. So the first thing that you have to know about R1C1 is that the way that we reference a absolute cell, so a kind of a deterministic reference to an explicit specific cell, is by writing the actual numbers after the R and C letters. What I mean by this is if I want to reference that cell, I begin with the letter R, that represents the row that I want to capture. And in this case, it's row number 4. And you can see that the blue highlighting box has now appeared to show exactly what it is that I'm targeting. After that, we put C, that represents the column. And then after C, we put the actual number of the column that we want to reference. So in this case, it's going to be column 2. So if we have a syntax like this, equals R4C2, row 4, column 2, that's going to get us the value hello. So that's how you make absolute references in R1C1 notation. The real benefit of R1C1 notation, however, comes from relative references. Let's just dive into a few examples in this lesson, and then in the next one I'll show you an actual example with a real-life problem that you might face. So what I'm going to do here is just clear this content, and let me go ahead and place a random value in one of these cells. Let's just say row number 6, column number 4. I'm just going to write a value like 5. And what I want to do here, after I just make it a little bit more definitive, let's bold it, center it both ways. Let's say I want to reference this cell from a bunch of cells around it, but this time I don't just want to use the absolute reference of R6, C4. I want to target it relatively from where I currently am. So for example, let's say I'm going to start in this cell right here, row 4, column 4. The syntax is going to look like this. I'll begin with my equal sign, and I'm still going to begin with my R here. And what I need to do here is I need to move downwards. And the way I do that is with actually square brackets. So I can't just write number 2 here, because if I write number 2, then it's going to interpret it as row 2. But if I put square brackets, the number in here represents the number of rows that I want to move downwards. So if I put 2 here, what this means is 2 down from the current row. So now you can see we're highlighting the proper row, row 6. Now, how do I stay in the same column? Well, if I just do C by itself, we could do something like write the manual reference of C4, but there's really no need to do that because it's going to be less dynamic. If we write just the letter C, the way this works is it's going to know the column you're in and it's going to substitute it. So just the letter C means the current column. So this syntax is, again, going to go 2 rows down, same column. And it's going to reference the value in that cell. So we're going to get a 5 in there as well. We've copied that value. Let's take a look at another example. This time I'm just going to navigate a little bit below, maybe 3 cells below. And once again, we're going to begin with an equal sign, just to do a few more practice runs. We're going to begin with R, but this time we want to navigate upwards relative from where we are. So we know that whenever we want to navigate, we always have to do the square brackets, otherwise it's going to be a literal reference. But this time, if we put a positive number, we're going to move downwards. So in order to move upwards or backwards, you actually have to provide a negative number. We want to move 3 rows up, so we have to provide a value of -3. Once I close this, you can see the right row is highlighted, and now we still want to stay in the exact same column, so I can just put the single letter C, and that's going to target the 5 in this cell and represent it right here as well. 2 more examples. Let's attack this number from both the west side and the east side. Let's say I start right here in row 6, column 1. Once again, we're going to put an equal sign. Now this one is a little bit different because now we have the situation reversed. We want to get the value that's currently it's number 5, but we want to stay in the current row. So now when I write R, I'm not actually going to write anything afterwards, neither a number nor a square bracket with a number, because that would be either an absolute reference or a relative movement. In this case, I want to stay in the exact same row. So this is done. However, when it comes to columns, this time around, I do need to provide something to columns in order to actually move to where I want to go. And again, I can provide C4 here to target column 4, but I want this to be dynamic. So how can I actually move? Well, I want to move 3 columns over, from column 1 to column 3, and then it simply becomes a mathematical calculation. If I want to end up in 4 and I'm currently in 1, I have to move 3 over. So I can provide a positive value of 3. 3 in square brackets when it comes to columns means rightwards, and when I execute this, we're going to get the exact same result. One more example right here. Let's say I move somewhere immediately to the right of my original cell. Same idea. We're going to use R here to stay in the same row. We're going to use C, and we want to move now backwards. And it's the exact same logic as moving upwards when it comes to rows. Whenever we want to move leftwards with columns or backwards, we have to provide a negative argument. In this case, I want to move 1 to the left. And again, the way you can think of this is I'm in column number 5. How do I get to 4? 5 minus 1. So you can think of it as a mathematical expression like Excel does. And when I execute this, we're going to get the exact same value. So in this lesson, that's really all there is to cover here. We talked about the R1C1 notation and the different ways that we can reference cells within R1C1 notation. We talked about absolute references. In that case, all we do is we just write R followed by the number of the row, and then C followed by the number of the column. We can also leave either R by itself or C by itself. That's going to reference the current row and the current column. And finally, we have that square bracket notation, which is a dynamic relative movement. So a positive value for rows means downwards, a negative value means upwards, and a positive value for columns means rightwards, and a negative value means leftwards. It's a lot to take in, so I recommend you do an exercise like this. Just put a value somewhere randomly in this sheet, find some random cells around it, and see how you can navigate to that cell. In this lesson, we kind of take a look at some of the basic examples, but try an example where you have to provide negative arguments to both R and C, or positive arguments to both, or swapped arguments, negative, positive, negative, etc. In the next lesson, we're going to take a look at how we can apply this to a real-life math problem, or a real-life Excel problem, rather, and you'll see some of the benefits of R1C1 notation, especially as compared to A1. I'll see you there. All right, let's now take a look at how we can use R1C1 notation in the context of a real-life Excel problem. Let's begin with something basic like a 2-column sum. So right here in column 1, I'm just going to populate a few numbers, 1, 2, 3, 4, 5, and right here to the right, let's do a couple more, 6, 7, 8, 9, 10. And let's say in column 3, I just want to do the sum of the numbers that are 2 to the left, or rather the cells that are 2 to the left. How can I accomplish something like that? Well, we begin with the equal sign, of course, and then we're going to need the sum function. And let's open it up. And let's say I just want to feed these arguments with the colon syntax, so from this cell to this cell. How can we accomplish something like this? Well, I have to begin by targeting the cell that is 2 to the left. The way I can do that is I know that I want to stay in the exact same row, so I can keep the R by itself. I then use my C syntax, and now in order to navigate or move, I have to provide my square brackets. So I want to move 2 to the left, 2 columns to the left, so I have to provide a negative 2. Again, as a reminder, if you're starting in column 3, the way you get to column 1 is by subtracting 2, so you can put a negative 2 there. After I close the square brackets, I can put a colon. That's going to delineate where the beginning of my range begins and the end of my range. So now I have to put the endpoint. So it's still going to be the same row, so I'm just going to use R again. It's going to be, again, the C, and I once again have to use the navigation syntax, which is the square brackets. But this time, I want to move only 1 column leftwards or backwards. So it's going to be negative 1. And if I close this and then close the sum formula, we're going to get the right result, which is 7. Now, here's the beauty. You can probably recall what this would look like in something like A1 notation, where if we were to just drag this formula down, each cell, Excel would figure out the right letter references and the right row references and stuff like that. So let me actually show you how this would look in, let's say I'm just going to copy it down right here and go back to our original Excel view. So if I go to File, Options, and Formulas, and R1C1 Reference Style, we can actually see right here that our formula is being copied down A1 through B1, A2 through B2, and this is all great. However, you'll notice that each cell is actually containing a totally different formula. Here's the beautiful part about R1C1 once I go back to that option. We can actually, if you think about it for a moment, what you'll realize is that the formula right here applies to every single cell, right? Because no matter where we're starting from, let's say we start somewhere here, the logic is the same. We want to take the sum of the whole range from 2 columns to the left to 1 column to the left. So as we drag this down, let's say we complete it all the way to here. If I navigate through these cells, you'll notice that the formula is actually not changing, right? So it's a lot more intuitive now because we don't have to actually look at that dynamically changing value of the column or the row. Now it's the exact same formula. And this is exactly how Excel is able to figure things out behind the scenes. So this is one benefit of something like R1C1 notation, is that we have a lot more consistency now in our formulas. It's a one way of writing things and it just logically makes sense. Let's take a look at another example with both relative and absolute references. I'm going to transition here to sheet number 2. And let's say I want to write a basic spreadsheet to calculate the tip that I want to pay on a restaurant bill. So I can do something like this. I'll have a column here called price, and a column called tip, and a column called total. And in this column, I can just have a random list of numbers. This represents my total restaurant bill. Let's just do something like this. And let's say the tip is going to be determined by a percentage, which I'm going to place in this cell right here. And let's say I want to tip 15%. So I'm just going to put 15%, put that in here. So this is actually an example that's going to require us to use both absolute and relative references using R1C1 notation. So the first thing I have to do is to calculate the tip, which of course is the price times the percentage. So how can I do something like that? Well, I can begin with the equal sign. The first thing I want to do is reference the price, which no matter what cell I'm in here in the tip column is always going to be 1 column to the left. So I want to stay in the current row no matter which cell I'm in, but with the columns I want to navigate 1 to the left or 1 backwards. The next thing I want to do is to take this number, this value, in this case 10, and multiply it here with the asterisk times the value that's in this cell. However, this is an absolute value because no matter where I am in these cells, I always want to make sure I'm referencing this one, row number 1, column number 5, right? Because this is a static fixed value. It's not dynamically changing. It doesn't need to change row to row. We always want to make sure we're targeting this cell. How can we absolutely target a cell? Well, if we don't use square brackets and we use R followed by a number and then C followed by a number, that is an absolute cell reference. So we want row number 1, R1, and column number 5. R1, C5, no square brackets, and no R or C by itself. This is an absolute reference to that cell. So when I execute this, we're going to get 1.5. That's exactly right. That's 15% times 10. We can go ahead and drag this down. And again, you'll see the beauty here is that this formula is still not changing because the logic is always the same. Take the value 1 column to the left, multiply it by the static value in this cell right here. Right now, the next thing we have to do is to just add these two numbers together, and we can use the exact same logic we just saw on sheet 1. So we can do something like this. We want to do the sum. In fact, let's do something different. Let's just do the plus symbol right now to vary things up a bit. I can say, all right, stay in the same row, go back 2 columns to the left, and let's add, stay in the same row, and go back 1 column to the left. All right, we're going to get 11.5. That's the right answer, 10 plus 1.5. I copy this down. Again, as I scroll down through these cells, keep your eye on the formula bar right here. You'll notice the R1C1 formula is not changing. This is a pretty powerful feature, and not just here in actually Excel. I know there are some developers and even Excel users who keep R1C1 notation on all the time because they just think it makes it more intuitive. It's more mathematical. You can think of both your rows and columns numerically. But even if you're going to be sticking with A1 notation in your Excel interface, this kind of thinking as far as navigation, thinking of 2 cells down or 3 cells to the right, relative references, this kind of thinking will help you a lot when it comes time to write your macros, because many times you're going to be doing some kind of process in coding where you're going to be in one cell, you're going to need to use that cell's value to perform some kind of calculation, and then, for example, paste the new calculation 1 cell to the right or 2 columns to the right. And having the perspective of being able to look look at this grid kind of in this intersection of a row and a column is going to be a lot more helpful and beneficial when you're figuring out where to paste that value compared to thinking about it in terms of letters, right? Because column A, column C, how do you move from here to here? Do you have to like concatenate a number to a letter and in a range reference? It becomes a lot more complicated. It's a lot easier when you think of everything as just being referenced by a number. Before we conclude this lesson, what I want to do is make sure we bring us back to A1 notation just so you don't freak out and wreck anyone else's experience with Excel if somebody else is using the program. Again, as a reminder, we can go to File, we can go to Options, and then in this box there is a Formulas tab, and we can just uncheck R1C1 reference style, and this will take us back. And again, this will not only fix just the columns, it's automatically going to fix all the references in here. So these are all the exact same formulas that we wrote. The reason, again, that Excel is really easily able to convert back and forth between those two is because behind the scenes in the actual code base, Excel is using R1C1 notation for all of its navigation and movements and that kind of stuff. That's all there is to cover on the topic of R1C1 notation, so I'll see you in the next lesson. All right, so a couple lessons ago, we talked about the value and text properties, which allow us to get or set a cell value or the actual displayed text. And in this lesson, we're going to take a look at two more properties that we can use to actually get or set a value in a cell. And those two properties are formula and formula R1C1. Let's begin with the read-write formula property, which can be used to set a cell to use an actual formula. For example, in the Excel interface here on the left-hand side, I have two values here, 3 and 4. And let's say I want to write in a sum function in here, but I want to do it using VBA. Here's what I can do. Let's begin by declaring a procedure, and I'm just going to write it write formula. And what I want to do here is reference my cell of range A3. And this time, I'm going to use the property formula. And formula, I'm going to use the equal sign to set a value for that property. And this is still going to be a string. However, in this string, I can actually write the equivalent Excel formula that I want to use. So in this case, I want to use the sum. So I have to begin with the same syntax I would use in the main Excel window, equals sum. And now I can write a formula like A1 through A2, close my parentheses, and it's the exact same as writing it manually right here. So when I execute this formula, this procedure with F5, we're going to get the right value of 7, and right here we can see that that has been written properly into the formula bar. Let's take a look at the actual differences again between the value, text, and formula properties, just so you can get a sense of how this data is actually being stored under the hood. So let's just write out a procedure here called, let's say, get cell formulas, or let's say get cell values is a better name. And right here, I'm just going to use a bunch of debug prints. Let's get debug prints range A3 value. Let's go ahead and copy this and just replace those property values at the end. Value, text, and then let's take a look at formula. So when I execute this with F5, you can see that value and text are both going to give me the exact same result, which is 7. The advantage, of course, of formula right here is that it's actually going to give me the formula that was used as the basis of calculating that cell. We can't see this right here unless we click into the cell and actually take a look at the bar here. But we can extract it right here with the syntax when we're using the get property, when we're getting the property value rather than setting it. And of course, we can do anything we want with this string, such as manipulate it or the like. So again, these properties all serve a different purpose, depending on whether you want to get the actual value that's stored in a cell, the actual number, the displayed text, or the actual formula in this case that's being used to calculate the value that's being displayed in that cell. Let's take a look at one more example. Here on sheet 2, I have a different data set. It's pretty simple, just 3 columns worth of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say I want to do the exact same thing as I did a moment ago. I want to write the sum formula here. However, this time I want to do it using R1C1 notation. Even though we don't have that setting enabled right here, we can actually use it within our VBA code. And you can see some of the simplicity of that in just a second. So let's go ahead and define a new procedure here. Let me just create some space. And I'm going to call this one calculate totals. My sheet 2 is now going to be my active sheet, so I don't have to explicitly reference it. I can just go ahead and target my range. And I want to make sure this formula is populated across all of these 3 cells, so I can target range A4 through C4. So in my string here, in my double quotes, A4 through C4. This time around, I want to target the formula R1 C1 property. And as you may recall, perhaps you may, perhaps you may not, this is actually the property that the VBA macro recorder uses whenever it's actually recording your macros. So this is the default thing that it uses behind the scenes. So if you don't remember the syntax from earlier in the course, feel free to watch that video and you can take a look at how VBA does it behind the scenes. So this is actually going to take another string, but this time around, we're still going to be using sum. This time around, we're actually going to be providing the arguments in R1C1 notation. And so the beauty here, again, is that we can provide a single formula here because, again, R1C1 is the same formula no matter what cell you're starting from. If we had to do this manually and we had to figure out, hey, A1 through A3 or B1 through B3, we'd have to make our code a lot more elegant and it would be a lot more difficult to put together compared to an R1C1 formula, which is going to be pretty simple. No matter what cell we're in row number 4, we just say, hey, we want the sum of the 3 cells above it. So the way we can do that is we stay in our current row, which is always going to be row 4 for all of these 3 cells, and we want to take the sum from the starting from the row that's 3 above, which is row number 1. So from where we are now, we can move 3 rows up, again with that negative notation, and we want to stay in the exact same column, so I'm just going to put a C here, and we want to sum from that value all the way to the row that is 1 above. In that case, that's going to be row 3, and still stay in the same column. And then the last thing we need to remember to do here is to actually close the sum function. So again, what this is going to do, just to give you an example, let's say we are targeting this cell right here. It's going to go 3 rows up, which is right here, and take the sum from that to the row that's 1 row up, which is number 6 in this case. Take that sum, calculate it, and write it into here. So we can go ahead and execute this code. Let's press F5. And we can see everything is being written. Even though we used formula R1C1 right here, we can see that it's using plain A1 notation right here in the main interface. But the beauty of this is that we don't even have to think about the letters anymore, whether it's B1 or C1 or A1. We can just think about the formula rather, the relative formula, and this singular formula will apply across the entire board. That makes the process of writing these values and these calculations a lot easier. Believe me, these kinds of references with R1C1 notation really shine when it comes to challenges like this. That's all there is to cover in this lesson. We talked about the formula and formula R1C1 properties, 2 more properties in addition to value and text that are available on range objects that we can use to actually set the value in a cell or set the presentation value in a cell, etc. Play around with these 2. These are pretty popular in professional VBA code, especially when we're doing a lot of repetitive operations, for example, repeating the same thing like we are here in row 4, or for example, moving downwards in a column and performing some kind of consistent calculation on every single cell. It's very easy to write one R1C1 formula and have it do the exact same thing everywhere where it's needed. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the offset property on a range object. The offset property is used to perform navigation or traversal. We start at a given range, then we specify how many rows or columns we want to move, and Excel will move that range to somewhere else in our worksheet. Let's take a look here in the immediate window. Let's begin by targeting cell A1. That's going to serve as our starting point. So I'm going to say range A1, and let's just call the select method so we can highlight it in Excel. There it is, our top left corner of our worksheet. So let's go ahead and use the offset property. When I open the parentheses, the tooltip is going to tell us that the offset property expects 2 arguments. The first is row offset and the second is column offset. And this represents how many rows we want to move and how many columns we want to move over from where we're starting from. A positive value for the row offset argument means that many rows downwards, and a positive value for the column offset property means that many columns to the right. So for example, if I want to move 2 rows down and 0 columns over, I can write 2 rows down, comma, 0 columns over. So if I use select on this resulting range, that's what we're going to get back, a brand new range. You can see we're going to end up with a range of cell A3. That's because we started in cell A1, then we moved down 2 rows and 0 columns to the right. We can, of course, move to the right as well. So let's say we start in cell A1. We want to move 0 rows down and 5 columns to the right. If I execute this, we're going to end up in cell F1. We can, of course, combine positive values for both the row offset and column offset arguments. So if I want to move 2 rows down and 3 columns to the right, I can do that. And this will take us from cell A1 to cell D3. Now, what do we do if we want to move upwards or leftwards? In that case, we need to provide negative arguments. We provide a negative integer for the number of rows that we want to move up, and a negative integer for the number of columns that we want to move to the left. So we have to start somewhere else compared to our top left corner, which is sort of a boundary in the window. So let's start somewhere like cell C5. And let's say I want to move now, let's say -2 rows, which means 2 rows up. So let's take a look at where that gets us. We're starting out in cell C5, and we're going to end up in cell C3. So here's where we started from. An argument of -2 means 2 rows upwards. That's going to take us to cell C3. Similarly, if I want to move to the left, what I can do is move to the left with a syntax like this. This means 1 column to the left of where we're starting from. So from cell C5, that's going to take us to cell B5. We can, of course, combine negative row offsets and negative column offsets if we want to move both upwards and leftwards. So for example, let's say I want to start in cell, how about F8 right here? So let's do F8. And if I want to move 5 rows up, I can provide -5. If I then want to move 3 columns to the left as well, I can provide an argument of -3. And that's going to take us to cell C3. Here's the coolest part about the offset property. So far, we've only been taking a look at a single cell, but as it turns out, we can target a range of any size, including a range with multiple cells. So for example, let's create a 3x3 range at the very top left of our spreadsheet. So if I target something like A1 through C3, that's what that range looks like currently. It's selected there in the interface. What I can do is call offset, and let's say I want to move this 10 rows down and 3 columns to the right. When I select this to take a look at where we're going to end up, we're going to get the exact same range right here. So the shape, the dimensions as far as the number of rows and the number of columns has not changed. We've retained the shape of the range, we've just moved it, we've traversed it from its original starting point, however many rows and columns we specify with the offset property. And again, we can also provide a negative argument here as well if we want to move this entire range upwards or leftwards. That's all there's to cover here. The offset property is very, very popular among developers because many times we're going to be iterating. We'll dive into that a little bit later in the course, but many times we're going to be iterating, which means going through a collection of values, for example, in a column, and doing some kind of calculation to that value and then pasting that somewhere else that's kind of parallel to where we're starting from. So for example, we may be iterating in column A right here through a bunch of values, and we may want to paste the calculation to the right of it. And the offset property makes that very easy because wherever we currently are cell-wise, we can use offset to automatically end up in the right position, for example, to the right or to the left or upwards or downwards. It's a navigational tool that's very powerful. We'll dive into some of these concepts a little bit later, so we're going to be coming back to offset many times throughout the course. But that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the resize property on a range object. Just as the name suggests, the resize property changes the size of a range based on the location of a single cell. Let me go through a couple examples here in the immediate window. Let's begin by targeting a cell like C2, so range C2. So an important thing to realize about the resize property is that it's always going to include the actual cell itself where it's starting from. The resize property expects 2 arguments, one to represent the number of rows that should be included, and 2, the second argument, to represent the number of columns that should be included. So if we're starting in a single cell and it's included, if we put an argument here of 1, 1, that basically means just the current cell. So if I do select here, because the resize property will return a brand new range object to us, we can see that's simply going to target cell C2. Let's take a look at a couple more examples here. Remember, the first argument here is the total number of rows that we want to be represented in the final range that we're going to be delivering here. So if I want to instead have 3 rows represented, starting from cell C2, what this syntax is going to do is it's going to start at cell C2, and from that single cell, it's going to resize that range to be exactly 3 rows and 1 column, but starting from C2. So if we take a look at this, we're going to get this entire range represented. Again, the original cell where we're starting from is included. So it's not 3 plus the cell where we're starting from, it's 3 including the cell where we're starting from. So this is targeting, again, 3 rows, 1 column. What if we wanted to instead target 2 columns? Well, it's as simple as replacing this second argument. So what this is going to do is target 3 rows, 2 columns, including the cell from which we're starting from. So we're resizing from a single cell to a range that now represents this 6 total cells, 3 rows by 2 columns. As I mentioned, the resize property returns a new range object, so all of the available functionalities, properties, and methods are all there and present for you. So for example, let's say I want to start at range C2, but I now want to target, let's say, a 4 by 5 block from that position. Again, I can do resize, let's say 4 rows, 5 columns. That's going to give me a new range object, and let's say I want to write in the same value into that entire block that I've just created. I can do something like this, the value 25, and now we're going to get this written output right here. So again, just to show you this, because this original selection is still highlighted, we're starting here in C2 right here, and then we say we want to resize from that cell 4 rows and 5 columns. So starting from here, 1, 2, 3, 4 is 4 total rows, and starting from that top left cell, 1, 2, 3, 4, 5. That's how we resize. It's now going to give us back a brand new range object. So pretty handy property to have in your tool belt. The resize property changes the size of a range based on the location of a single cell. By the way, if you feed the range, the original one, a clump of cells, for example, if this was something like C2 through, let's say, something crazy like H17, the actual result would not change at all because it's always going to use the top left cell as the starting point. So it's really meant to be used with single cells. Once you have that starting position, you simply use the resize property and specify how you'd like to expand it or resize it. Just give it the rows and the columns. If you want to stay in the same row, you just do an argument of 1. If you want to do the same column, you just do an argument of 1, or rather if you don't want to expand it. So don't be afraid, as we just saw a couple moments ago, an argument of 1, 1 simply means the current cell, and we can expand it in whichever direction we want. We don't necessarily have to expand it in both the rows and columns direction as we did here. That's all there is to cover here, so I'll see you in the next lesson. So far throughout the course, we've been using A1 notation whenever we've referenced a range object. It doesn't matter if it's one cell or multiple cells. We've always used a letter to represent the column and a number to represent the row. Well, now the time has come for us to explore an alternate syntax that we can use to select a range object, and that's the cells property. The cells property actually relies on R1C1 notation, which, as we just learned, relies on a number for both the row and the column. Let's take a look at this in action in the immediate window. Cells is actually a property on the top level application object at the top of the hierarchy. So if I write out application, I'll see that cells is immediately available here, and I can use it like this. However, as we know by now, application many times is not necessary as a prefix because VBA can figure these things out. So I can actually just write cells by itself, and by default, this is going to target the entire spreadsheet, so every single cell on it. In fact, I can prove this by using select. So you might wonder how we're able to use select, and the answer is cells right here is going to return a valid range object. So simply by writing cells, this is a range object for every single, the collection of every cell in the worksheet. So all of my range properties and methods are available here, including select. So I can write select here, and that's going to highlight every single cell on my worksheet right here. Of course, the more powerful way to use this property is by providing it a value for both the row and the column. The way we can do that is by feeding it a pair of parentheses, and right here VBA is giving us a hint, row index and column index, and this represents, of course, the row and the column that we want to reference. So let's say I want to reference row number 2, column number 5. I can just enter that, and that's going to give me a range object that represents that one cell. I can call the select method on this, and we're going to see that that's cell E2. Even though we still have A1 notation enabled on our spreadsheet, we can still use cells right here in VBA. And again, this is a completely valid range object, so I can do whatever I want with it. For example, with this range, I can use the value property to set that cell to a value of 25. When I execute this, it's going to be the exact same as writing range E2.value equals 25. It's just an alternate way to reference a cell, but using row and column numbers. Now, cells, unfortunately, can only accept a row number and a column number. So what do we do whenever we want a range with multiple cells within it? Well, we have to use the familiar resize property because remember, that starts off at a cell and is able to expand to include a much larger range. So remember, for example, if I do something like this, cells, let's say something a little bit closer to the beginning, like cell 2, 1 is going to represent row number 2, column number 1, so cell A2. Once I have the cell, this is a valid range object, so I can use the resize property. and then expand that to a larger size. For example, I can do 4 rows downwards and 5 rows to the right. And when I highlight this, we can see that it's done exactly what I expected. We're starting out right here in cell A2, row 2, column 1. We're going 4 columns down and then 5 columns over. And again, resize is also giving me back a valid range object. We're continuing to get back range objects every single time we do some kind of operation here. Cells is giving me a range object. I'm using a resize property on that range object to get back another range object, and then I'm using a method on that. I can just show you another example here. We have the value property available on a multi-cell range as well if we want to overwrite all of the cells. So I can give it a value here like fill, and it's going to write it in all of those cells. That's really all there is to cover here. It's a very quick introduction to cells, but I promise we're going to review this concept a lot as we proceed throughout the course, because cells really becomes much more powerful when we have to do multiple operations over, let's say, a range of cells. For example, when it comes to iteration, which is the process of going over one cell at a time. For example, going through every value in column A, performing some kind of calculation, and then writing the result in column B. For that kind of process in VBA, using a syntax like this that uses row and column numbers makes things like mathematical addition, calculation, subtraction a lot easier. We just saw an example a few lessons ago when we talked about R1C1 notation, how it's a lot easier to navigate across columns when you think of them numerically rather than alphabetically. And I assure you that this syntax will pop up a lot of times as we proceed throughout the course, and you're going to see more of its use cases. But for now, you can practice using it just by yourself whenever you're writing some kind of macros on your own. Try to replace your range references that use A1 notation with cells references that use numeric references for both rows and columns. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll talk about the current region property on a range. It returns a range that is bounded by, or surrounded by, or enclosed by any combination of blank rows and blank columns. Unfortunately, when it comes to real-life data, it's not always going to be picture perfect. There's going to be gaps and missing spaces and missing columns and missing rows. For example, you may have data that looks something like this. I've created these 4 separate blocks or ranges of cells, and let's imagine they all have valid pieces of data, but they are surrounded by these unfortunate white cells, these blank cells. How can we actually select the actual enclosed range? For example, just the blue cells, or just the green cells, or just the red cells. For something like that, we can use the current region property. Let me show you how this works in the immediate window. We're not going to actually be writing any procedures throughout this lesson. So let me go ahead and pull this up, and we're going to write all of our code right here. What current region is going to do is look for the boundaries of a given range. So no matter where we start, it's going to move in all 4 directions, north, south, east, west, and look for wherever that range concludes. And of course, the conclusion is wherever it runs into an empty cell. So for example, if I begin at range B2, and I access the current region property right here, that's going to give me a brand new range object, and I'm just going to call the select method on it just so we can activate it and see it in actual action. So when I execute this, if we take a look on the left-hand side, we're actually going to get cells A1 through C3. So what's actually going on here? We're starting out in cell B2 right in the center. And just like I mentioned, you can almost imagine Excel as going in every single direction up until it reaches an endpoint or a border. So it's going to go up, it's going to reach the top of the spreadsheet, there's no endpoint there. Same thing with the left side. It's then going to move all the way down to here and see that we have some values on row 3. And it's also going to move to the right to column C and see that we have some values here. And as long as it's not going to run into any kind of blank cells, it's going to close off the entire section, the entire range. It doesn't matter, by the way, if this is range of B2 or if we start in something like cell A1, that's going to give us the exact same result. Or, for example, if I start in cell C3, that's going to give us the exact same result. It's simply going to find the boundaries or the borders around that cell that we pick as our starting point. The same rules will apply in any of these 4 boxes. For example, if I go ahead and select a cell in the green box, like let's say cell A7 on the bottom left, and I select that, that's going to select the entire green box. It's again going to look for the limits or the boundaries of that collection of cells up until it reaches the blank values. Similarly, if I target something in the yellow box, for example, let's say cell G2 right here, that's on the right side of my yellow box. That's going to be able to figure out the entire boundaries of the yellow box. Finally, if I pick something in the red box, like let's say the left-hand side of E6, if I do E6, and I activate this, we're once again going to get the entire red box. It's found the current region of that cell. Now here's a challenge for you. What happens if I select a range that's actually going to include a couple of blank cells? For example, if I select the entire range of all of my boxes, A1 through G7, and on that range I select current region, what do you think I'm going to select here? What's actually going to happen is it's going to move in a direction of upwards and leftwards and select the first inner range that represents a complete box or a complete region. So in this case, if we target the entire range, it's actually going to highlight the blue box at the top left. It's going to look for the first enclosure of cells anywhere within this range that we've given it. It's going to look for it from the top left perspective. So it's going to find the first one that is the most to the top and the most to the left. As another example, let's say I'm going to select right here cells E1 through G7. So this, in this scenario, is selecting this entire clump of cells right here, the yellow box and the red box. In this case, it's going to move, again, upwards and leftwards. In this case, there is no leftward motion, but if we select the entire thing, what it's actually going to select is just the yellow box. That's the general direction in which it's going to move, upwards and leftwards, in its search for some kind of range object that is enclosed by a blank cell, some kind of defined space of valid values that is enclosed by blank cells. Hopefully this gives you a sense of what the current region property is really helpful for whenever you have a sea of values and maybe some of them are clumped together and they're surrounded by blank cells and the data isn't in perfect order. The current region property allows you to dynamically figure out where one range ends and sort of select all of the cells that are contained within it. Pretty powerful feature. Go ahead and explore it some more in your free time. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the end property of a range object, which simulates the press of an end key in a directional arrow on your keyboard. Now, the end feature is not something that everyone is familiar with in Excel, so I want to begin by offering a brief review of this concept in the actual Excel interface. I'm going to click into cell A1, and on most keyboards, you're going to have a key called END, E-N-D. I'm going to click mine, and as soon as I press it on the bottom of Excel, we're going to see this update that says End Mode. What this means is that Excel is expecting us to press one of the 4 directional arrow keys, up, down, left, right. And what it's going to do is move in that direction. Now, when we have a spreadsheet like this that's completely empty, pressing an arrow key like down is going to move all the way down until it reaches the end or conclusion of this worksheet. So right now, I'm in cell A1 in end mode, and when I press my down arrow key, I'm going to go all the way down to cell, or row rather, 1,048,576, still in column A. What if I want to use this exact same technique to move to the right, so the bottom right corner of the spreadsheet? Again, I press the end key. That enters us into end mode. I then follow that with an arrow key. So for example, I can press my right arrow key. That's going to take me to the bottom right corner of the spreadsheet. If I want to go back up, I press end, followed by the up arrow key. That takes me to the top right corner. And if I want to end up back where I started, I can press end, and from right here, I can move leftwards back to cell A1. An important thing to note here is that this is the standard behavior in an empty worksheet, but it's going to work a little bit differently if we have cells full of valid data. For example, I'm just going to create a couple cells here of random values. It doesn't really matter what they are. Let me, in fact, put a couple more right here. And the way this is going to work, we're once again going to start in cell A1. But if I press the end key right now and press down, it's not going to move to the bottom of the entire spreadsheet. It's going to move to the bottom of the current range, which means the last cell that has valid data. So if I press down right now, that's going to take me to cell A8. If I press end and down again, well, that's going to bring me back to the bottom of the worksheet. I'm just going to come back up by pressing end 1. That this time is going to take me to cell A8. So the similar behavior, but in reverse. It's not going to take me to the top of the spreadsheet. It's going to take me to the last cell that has valid data in it. So as another example right here, if I go into, let's say, cell A3, and I press end and I press right, it's not going to move to the right end of the worksheet. It's going to move to the right end of the range that I'm currently in. If I press end down, that's going to take me to this cell. If I press end left, that's going to take me to this cell, and so on. Hopefully this is a good enough explanation, and now we can go ahead and translate this type of behavior into VBA code. What I actually want to do here is to write a procedure that's going to write a value into each of our four corners. The northwest corner, cell A1, the southwest corner, which is the lower left corner, the southeast corner, which is the lower right corner, and the northeast corner, which is the top right corner. So just like we navigated it just a minute ago, I want to do that exact same thing, but using VBA code, and I want to write actual values into those cells. So let's go ahead and write our procedure right here. Let me actually bring down the immediate window a bit. And I'm going to call this procedure change corners. Now we can begin with a simple reference to cell A1, range A1, and we can just give it the value of a string of top left corner. This is a pretty simple one. And so what we need to do here is we're always going to begin with a valid range. It doesn't really matter where we begin, but for the purposes of this exercise, I'm always going to stay consistent and start with range A1. That's the most logical step. Before I proceed here, actually, I do want to make sure that I clear everything right here just to ensure we don't run into the problem that we just saw where we have valid range data right here. So I'm just going to clear all this data right here. We have a completely blank spreadsheet and we are good to go. So let's talk first about writing a value in the bottom left corner. So we have to simulate going down. That's pressing the end key and then pressing the down arrow. How can we simulate that behavior in VBA? Well, I can put the end property right here, dot end, and this is going to expect an argument, and it's actually going to be a predefined constant or an enumeration. Remember, these are values or keywords that are built into Excel, and they're going to evaluate into numbers on the back end when VBA is actually processing our code, and that's going to allow it to figure out what it is that we want to do. So there are actually 4 enumerations available in this total category called Excel direction, and those are Excel down, Excel up, Excel to left, and Excel to right. It's a little bit confusing because left and right don't follow the exact same naming scheme, but down and up are pretty simple. It's just going to be Excel followed by down or up. So if I want to move downwards and simulate a down arrow press, what I can do is give it the enumeration Excel down. We see them all listed right here. So I can press tab to lock this into place, close this, and this is going to take us to the actual range. So this is going to return back to us a brand new range object of a single cell, the bottom left corner of our spreadsheet. I can attach the value property right here, and let's write in bottom left corner. All right, it's going to be the exact same process when we want to access the top right corner of the spreadsheet. We're going to start at cell A1. We're going to use the end property, but we have to give it a different constant so it knows which direction to move. This time we want to move to the right, and it's not going to be Excel right. I know it's a little bit confusing. It's actually going to be Excel to right. It's a little bit of a different naming convention. I don't know why. Perhaps there's a technical reason for this, but 2 of these enumerations have one way of being named and the other 2 have another. So when it's moving leftwards or rightwards, it's going to be to right and to left. So Excel to right, otherwise this is going to take us in the exact same logical direction. It's going to take us to the right, and once we're at the top right corner, we can access that range's value property and write in top right corner. All right, accessing the bottom right corner from our original starting position is going to be a little bit more difficult, but totally doable. So we can actually approach this in one of 2 ways. I'm going to write out both just for this example. Let's begin by moving downwards to the bottom left corner and then moving rightwards to the bottom right corner. So I can begin with an end and give it Excel down. This is going to take us all the way to the bottom left corner of our spreadsheet. And what I can actually do, because this returns back to me a valid range object, which has its own set of properties and methods, I can continue chaining on additional end properties, right? Because this is evaluating to a completely valid range object. So on this range, I want to do another end, and this time from the bottom left corner, I want to move to the right. This is going to take me to the bottom right corner, and so I could write in my value in that range, bottom right corner. You can probably guess the syntax for the alternate approach. If we're starting at range A1, we can move, instead of downwards, we can move all the way to the right. So Excel to right is going to take us to the top right corner of the spreadsheet. That's going to give us a range object. We're going to use the end property on that range to move downwards. That's going to take us to the exact same destination, the bottom right corner. We can do dot value and write bottom right corner. And that's going to write the value in there. And that's basically all there is to it. So let's see if this works. I'm going to click into here, press F5 to execute. All right, so top left corner, let's now use the end arrow key and actually press down so we can see what happens here. There is our bottom left corner, end right. There is our bottom right corner with its value, and end up, and there is our top right corner with its proper value. And that's all there is to cover in this lesson. We talked about the end property, which simulates the press of an end key and a directional arrow on the keyboard. This is a common feature in Excel, but not everyone is aware of it, so I wanted to give you a brief introduction or review of it. You just access the end property on the range object when it comes to writing it out in VBA, and you give it one of these 4 predefined constants. They're part of the Excel direction enumeration. 4 possibilities: Excel down, Excel up, Excel to left, Excel to right. It's going to move in that direction. Again, on a blank spreadsheet, it's going to have this approach, but if you're dealing with cells full of data, it's going to move to the last cell that actually has valid data, so watch out. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the count and count large properties on a range object. They work in the exact same way. They return the number of cells that are contained within that range. The count large property can simply handle much greater and larger numbers. Now, an important thing to note here is that the cells themselves in the range do not need to contain content. It's literally just a count of the total number of cells. For example, I'm going to stick to the immediate window here. If I want to target this range A1 through C3, that's going to represent this range right here, this 3x3 range. If I access the count property on that, I'm going to get 9. There's going to be 9 total cells within this range. It doesn't matter, again, if there's actually values in some of them and no values in the other ones. What's going to happen here is it's just doing a literal count. And we're not, of course, limited to strictly a range that is just small like this. We can target an entire column or an entire row. For example, I can do something like this, the range of all the cells in column A. I can just do A through A. And if I do this, we're going to get a count of 1,048,576, which is the total number of rows as well, or the total number of cells in a single row. I can similarly get the total count of cells in a single row. For example, I can begin at cell A1 and go all the way to the top right of my spreadsheet. That's going to be cell XFD1. XFD is the final column in my worksheet. So if I do this, I can get a count on that, and we can find out that within a single Excel spreadsheet, we have a total of 16,384 columns. Now, when do we want to use the count large property? That's whenever we want to deal with something that is very, very large and staggering. We're talking huge numbers. So for example, let's say I want to find out the total number of cells in this Excel spreadsheet. If I take all the cells across all the columns and the rows, how many total cells are there? Well, I can do something like this, columns A through XFD. So take the column at the most left and all the way to the column at the most right, column XFD. If I try to do count on this, I'm actually going to get an error in VBA. It's going to be this overflow error. And what that essentially means is that there's not enough memory in the implementation of this count property to actually figure this out. That's not a problem though, because we can actually access count large. And that should give us the value that we're looking for, which is this. Let me see if I can probably figure this out right here. This looks to me like 17,179,869,184 total cells. So within a single spreadsheet in Excel right now, we're dealing with potentially 17 billion cells. Pretty staggering number. And you'll find out that if you actually multiply the total number of rows, which we have right here, by the total number of columns, which we have right here, it's going to give you this exact same result. It's the total number of cells within the worksheet. That's all there is to cover in this lesson. We talked about the count and count large properties. They're both read-only, so you obviously can't overwrite them. They can target anything from one cell to a clump of cells to an entire column, an entire row, or an entire spreadsheet, and they simply return the count of how many cells are present in that range. In this lesson, we'll take a look at the row and column properties on a range object. Both of these are read-only properties, and they return a long data type, a whole number that represents either the value of the row or the column. So these are both working in R1C1 notation, which we explored a little bit earlier in this section. Let's begin with a simple one-cell example. In my worksheet, I have highlighted cell C4. Let's go ahead and target it here in my immediate window, range C4. If I access the column property on this range, it's going to give me the numeric value of the column. This is column C, which of course is column number 3. Similarly, if I ask for the exact same range as row property, I'm going to get a value of 4. It is in column 3 and row number 4. What's going to happen if I expand this to a much larger range? For example, I'm going to start in the exact same cell, C4, but I'm going to go all the way to something like J26. Well, as it turns out, we're actually going to get the exact same result. We're going to get a column of 3, and if I go ahead and copy this example right here and paste it below and move this column around and switch it with row, we're going to get 4. The way this is going to work is that VBA is going to move to the top leftmost cell of the range. So even if we start at C4 and move down all the way to J26, it's still going to keep C4 as the main point of reference and take the column and row of that cell. So it doesn't even matter how large the range is, whatever cell we're starting from as our top left corner is what's going to serve as the basis upon which these numbers will be calculated. One final thing to point out before we conclude this lesson, I know it's kind of obvious, but these values 3 and 4 are relative to the entire worksheet, not relative to the range. So what that means is this is the number of the column within all of the columns in our worksheet and the number of the row within all of the rows in our worksheet. It is not relative to the entire range, right? So it's not counting, for example, column C as column 1 in this case. Rather, it's counting column C as column 3 amongst all the columns within the spreadsheet. It's kind of an obvious thing when we're staring at it here, but there are ways in VBA to have the opposite effect where we count the leftmost side of the range as column 1 and the top left cell as row 1, etc. But in this case, it is relative to the entire worksheet. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the rows and columns properties on a range object. Now, I don't want you to confuse these properties with row and column from the previous lesson. We talked about that, and that returns a single number that represents the row or column in the top left cell of a range. In comparison, rows and columns, these plural properties, will return back a range object that represents one or more complete rows or columns. So whenever you want to target a range that's going to occupy an entire row or an entire column, this is a really effective way that you can target that. Instead of writing a syntax that's going to be like range A1 all the way to range whatever is the last cell on the top right of the Excel spreadsheet, that's not the most effective way to target an entire row or an entire column. We can use this simplified syntax. So let's go ahead and explore some of these concepts in our Visual Basic Editor. I'm going to declare a procedure here called target stuff. There's a lot of different syntax options to explore. So the first one I want to introduce you to is simply writing rows and columns without any kind of reference. It turns out that rows and columns are actually available as properties on the top level application object. So here's rows and here's columns. And of course, whenever we do something off of application, we don't literally have to write it out, so we can just write rows by itself. And this is going to give us back a kind of proto-range object, if you will, that is going to represent every single row within my actual spreadsheet. So what I can do is call a method like select, which is available on a range, and it's going to select every single row within my entire spreadsheet. I can do the exact same logic with columns, and we're going to get the exact same results. So when I click out of here, execute this, there you can see we're selecting everything here. And in fact, what we can do here with the helpful debug print is actually call the count property on any range object, and that's going to actually tell us how many rows are being represented and how many columns are being represented. An important thing to see here is that we're not literally counting the total cells within the range, we're actually counting the total number of rows within the entire spreadsheet. So if I do debug print rows.count and debug print columns.count, we can see here we have 1,048,576 rows represented in the entire spreadsheet, and then 16,384 columns. All right, so this is pretty cool. It's pretty cool to highlight everything in the spreadsheet all at once, but there may be some better use cases for this property. This really becomes much more powerful and handy when you can actually use it to target a specific row or a specific column as a whole. So here's a syntax that we can use to do that. Let me just go ahead and comment this out because we won't need it later. So if we write rows and we actually provide parentheses after, we can use those parentheses to target a specific row or column index. So for example, if I want to target row 2 as a range, I can simply write in the number 2. And if I do that, you can see I'm now going to be targeting row 2. If I want to target more than one row at a time, what I can simply do is provide a string argument, because the colon argument here will only work for letters. It's not going to actually work for numbers, so we can't do something like this by itself, but we absolutely can do it as a string. So what this means is select rows 2 through 5. That colon means through, starting from 2, ending at 5. If we do this, we can go ahead and select more than one row at a time. And we can use the exact same syntax to target one or more columns. And with columns, it's actually a little bit more expansive because we can either use letters or numbers. So I can either target a column with a number, like here is column 4. There we go, we're targeting column 4 or column D. We can also target a column with a letter. For example, here is column E. Perfect, column E. And of course, we can target more than one column at a time. Let me in fact shift this over. I think we got shifted over a bit. But if I wanted to target, let's say, columns B through D, I could simply write columns and write B through D, and that would give me the entire range of those 3 columns. There we are. All right, so the last thing I want to show you in this lesson is how we can use rows and columns on a specific range. Right now, we're calling it globally on the application object, but we can actually target a specific range. And what it's going to do is allow us to kind of target a column or row within the context of a specific range. So let me give you an example. Let me target a range. Let me do it right in the middle of the spreadsheet. Let me do something like B4 through, let's say, D12. Let me go ahead and select that range. So that's what that looks like. It's that little rectangular thing. And what we can do here is we can actually use the rows or columns properties on here. And what I can provide to this thing is actually an argument as well. So what I'm going to do here is write columns 2. So what is this going to do? This is actually going to target the second column, but within the context of my range. So columns 2 does not mean column B. In this context, within the range, it actually means column C. And it's not just going to be boxed in by the column, it's going to be boxed in by the lower boundary of the range, which is row 12, right? So what I'm targeting here, as I can show you with the select, keep this shape in mind as I select and execute this procedure. It's actually going to target just that specific column, the second column, within the context or confines of that original range, right? And if I wanted to, for example, target all of these cells within the column within that specific range and write in some kind of values, I can do that, all right? And we have a very similar syntax here. If I target range B4 through D12 again, we have a very similar syntax for rows. So here's my entire range. And if I want to target only the 4th row within this range, if I do rows 4 here, right? This is not going to literally target row 4. It's actually going to target row number 7 because 7 is the 4th row within my range of B4 through D12. So if you can imagine row 4 as the first one, the top of my range, this is going to be the 4th row starting from that top, which is going to be row 7. And I can select it, for example, here, and now we're going to target it. And we can, of course, target those micro ranges and do whatever we want to them. So I can write in a value here like, micro target. Execute that. And there you can see we've actually selected a column. That's the code from earlier. We've selected column 2 within our range. And then we've also written in micro target in row number 4. All right. So that's all there is to cover in this lesson. We talked about the rows and columns properties. They're available at the top level on the application object, in which case they can be used to target all of the rows, all of the columns, or a specific subset of rows or columns, which you can target with a parentheses syntax. Simply provide either a number or a string to target more than one at a time. And then we also talked about rows and columns as applied to a range object. It sort of makes that range object the context or the box in which the columns and rows will be calculated. So you can use the column syntax to target a specific column relative to the range that you've selected, or a specific row relative to that range that you've selected. All right, so far we've talked about the row property, the column property, the rows property, and the columns property. I have 2 more to add. I know it's a lot. It can get confusing, but all of these are helpful in the right situation. In this quick lesson, I want to introduce you to the entire row and entire column properties. And predictably, these begin with a single cell, and they are used to create a new range that represents the entire row where that cell is located, or the entire column where that cell is located. What I can do here is simply click into a random cell, let's say cell C3 right here, and I'm just going to review a couple properties here in my immediate window just so we have a better understanding of how all of these properties work in tandem. So first of all, on a range, we can either select this with range C3, or what we can actually do is use the convenient active cell property. Again, this is going to select the currently active cell, which is whatever the user has currently highlighted or selected or made active on their sheet. So this is automatically going to be a reference to cell C3 or whatever cell is currently clicked into. This is a valid range object. It's just referenced by active cell. So on this range object, we have an address property. That's going to actually give me the address of the cell. We can see cell C3 right here. On a range object, we also have a row property that's going to give me the row number as a number. So that's going to be row number 3. We also have a complementary column property that's going to give me the numeric value of the column. Column C is column number 3. And here's where I want to introduce you to these two new properties on this range object. In fact, this time we won't need a question mark. We have an entire row property, and that's automatically going to give us back a brand new range object that represents the entire row in which that cell is located. So we're now in row number 3, but we're only in one cell. So when I do entire row, it's going to figure out we're in that row and select the entire row as that range object. I can prove this by simply tacking on that select method on that new range, and you can see it's going to highlight this entire thing. I need to also click back into, let's say, another cell right now. Let's say right here. And let's show you the complementary example, which is going to be entire column. So now active cell is going to be column number 5, or column E. So if I select the entire column from that single cell, that's going to give me back a brand new range for all 1,048,000, I think it's 756 rows. It's going to select the entire column for all of those cells. And so now if I do select, we can see we're going to get the entire column highlighted right here on the left-hand side. That's really all there is to cover in this lesson. The entire row and entire column properties are really quick ways that we can begin with a single cell and use that as the basis to select an entire row or an entire column for some kind of additional operations on that much larger range object. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at a popular community convention for getting the last row of data in a worksheet. So far, all of the data sets throughout the course have been perfect. There's been no missing gaps, no missing cells, no blank values. That's not always the case when it comes to real-life data. Often real-life data has improper calculations or missing cells or missing values. We have an example right here in the Excel interface. I have a column A with a bunch of numeric values, and we can see that it's filled with gaps. We have missing cells right here and here, also right here as well. Let's say the challenge now is that I want to write a value to the row below the last row. So in this case, it would be row 15. How would I be able to get to the last row of valid data in this spreadsheet? In this case, it's row number 14. Well, typically, if we have a perfect range, if we have a range without any missing cells, we would be able to do something like the end property. We could click into this cell, then press end, then press the down arrow key, and that would take us to the end of that range, which of course wouldn't have any blank cells. Unfortunately, in this case, that strategy is not going to work because when I press end down, we're going to go to the end of the current range, and that's cell A3, because it's going to look for the next blank cell. And we can't ever predict exactly how many blank cells or gaps we're going to have in our data set. So what solution can we implement here? Well, we can attack this problem from the opposite direction. Rather than beginning at the top of our spreadsheet and going end down, what we can do is start at the very bottom of our spreadsheet. I'm talking all the way at the bottom left corner. So essentially A plus the last row, which is 1,048,576, something like that. If we start at the bottom left cell and we press end up, that will take us to the last valid row of data. Let me just show you an example right here. I'm going to navigate all the way to the bottom. Here I am at the bottom of my spreadsheet. Here I have all these blank cells, but that's totally fine because when we use end, it's going to go to the next cell that has valid data in it. So if I press end and press up, that's going to take me to row 14, which is the last row of data. And we can emulate this exact same logic in VBA. And this is the most effective, most foolproof way to get the last row of data when you're not certain if your data set actually has gaps within it. Let's take a look within my Visual Basic Editor. Let's write a procedure here. I'm going to call it find last row. And the first thing I'm going to do is actually declare a variable to store the integer that I'm going to be using to store my actual result. So I'm going to call that last row, and it's going to be a whole number. And now what we can do is assign last row, and here's going to be my logic here. I'm going to use the familiar cells property, and we're going to have to provide two values here, one for the row and one for the column. We know that the column value is going to be column number 1, but what do we provide for the row value? Well, we want to get the very last row in my spreadsheet. Now, I could write that in manually, but the reason that's not a good idea is because it's not backwards compatible. In fact, earlier versions of Excel have less rows. So if we put something like 1 million here, not all versions of Excel have 1 million rows, so it's going to trigger an error if used in earlier versions. That's not always the biggest of concerns, but there is a more elegant solution to this problem. As you may recall, we have a property here on rows called count. And if we simply do it on rows without selecting any specific rows, it's going to get us a count of the total number of rows in this spreadsheet, 1,048,576. Or if it's ran in an earlier version of Excel, it's going to get us that number, but it's going to calculate it dynamically on the fly. And what we can do is that number of rows also represents the last row, right? If there are 1 million rows in a spreadsheet, then the number of the last row is 1 million. So what we can do here is to dynamically calculate the last row. That's going to be a number, and that number is actually what's going to be substituted here as the first argument to cells. That's going to determine the rows dynamically. So this is going to give us the last row in the spreadsheet. I want to target the first column. So now with this syntax, I've targeted the bottom left cell of my spreadsheet. Now that I'm at the bottom left cell, what I can do is use the familiar end property. I have to provide that argument of the enumeration of which direction I want to move. If I want to move upwards, we have to provide the predefined constant XLUP, XLUP. Now that's actually going to get me to the range. So this is actually going to get me to cell A14. That's a range object, which is no good because last row is expecting a whole number. But once we're on a range, we can actually get the row number on a range object by using the row property. And that's the entire syntax. Start at the bottom left, and navigate up with the end arrow key and the end key, and then press arrow key of up, or simulate that action in VBA. Get to a range, take that range as row property to get the numeric value of the row, which is going to be 14. And afterwards, we can just output it to make sure we're correct. We're just going to do debug print last row. So let's go ahead and run this. When I execute this with F5, we're going to get 14. Let's just try a couple more times. Let me create a couple gaps here and then put another value here, like hello. When I execute this again, let me just clear this content. Click in here, press F5. Now we're going to get 17. Perfect. Let me write in a couple valid values, a couple invalid cells. Let's do something like 3 right here. Now we should get a totally different result. It should be 23. Execute this again, and it's working exactly as expected. Perfect. That's really all there is to cover in this lesson. Of course, if you want a nice challenge for yourself, what I recommend is writing the procedure yourself to get the last data column. So not the last row, but the last column of data in a worksheet. It's a very similar thought process. You're going to have to go all the way to the right side of the spreadsheet, then navigate leftwards, but otherwise the logic is the exact same, and it'll give you a good chance to practice the syntax. Otherwise, this is the most effective way that we can get the last row of data. That's a very common convention because we usually have to get to the last row of data, then perform our next steps below it. For example, add the next row or add the next tabulation, all of those results. So very popular convention in the VBA community to get the last data row is to use this syntax. Go ahead and practice it, and I'll see you in the next lesson.